In 1919, the now famous Eddington expedition ventured out to see whether gravity can bend light, a major test of Einstein's general theory of relativity. By viewing a total solar eclipse, they showed that the sun did change the path of starlight just as predicted, making Einstein and his theory world famous. Now, a whole century later, scientists have set out again to even more remote locations scattered across 4 continents. They will once more push the limits of astronomical knowledge, testing the same theory in a way Einstein could never have imagined. Their goal? To take a picture of a black hole, something so ambitious that it seemed impossible. Until now. The story of black holes begins as a puzzle. In 1915, Carl Schwarzschild noticed that Einstein's then new general theory of relativity predicted the existence of strange objects, known as singularities. They were places where his new equations describing gravity seemed to go haywire. Inside them was a bizarre place where time stopped and space became infinite. At the time, many scientists, including Einstein, considered them too strange to be worth seriously researching. Over the 100 years since then, however, evidence has piled up indicating that singularities do exist in our universe as black holes.
A black hole is the most mysterious object in the universe. It's when matter gets to be in such a small space and it's so dense that the force of gravity prevents even light from escaping. That's a one-way door from our universe.
We know they sit at the hearts of galaxies and they drive how those galaxies grow and how those galaxies die. They swallow gas and stars up. There are also these incredibly enigmatic and mysterious objects that live at the boundary between our 2 great theories of physics, general relativity, which describes gravity, and quantum mechanics, which describes the smallest things in the world.
If you want to make a test of the fundamental theories of the universe, you want to go to the most extreme laboratories in the universe, and a black hole is that.
But observing this most extreme laboratory requires an extreme instrument. The immense gravity of black holes is an obstacle to viewing them directly. No light can escape from them, and they are tiny, crushing huge amounts of matter into small points of darkness. Even as the existence of these strangest of objects became more widely accepted, seeing them directly remained an impossible dream. In fact, to achieve the necessary resolution to see black holes directly, a single telescope would need to be the size of planet Earth, clearly too large to be feasible. Instead, astronomers spent decades studying the effects that black holes have on the matter around them. But the dream of getting more concrete evidence of these exotic objects was too tempting to be simply forgotten.
We all understand from a mathematical point of view that black holes exist, but to actually see something is a very visceral experience, and I think important for science and also for us to believe in it.
In the late 1960s, a new technique changed astronomy. Called very long baseline interferometry, it enabled several telescopes to observe as a team, creating a larger virtual telescope that could overcome constraints on telescope size. As this